Welcome to the third approach in determining or detecting influential data in STATA, and that is the leverage approach, which focuses on a combination of unusual values, the effect of a combination of unusual values on the X variables. So here we use the hard statistics to compute the leverage of a covariant pattern, and which give us values from 1 divided by the number of observations up to 1. So we have a maximum value of 1. And the following are the suggested thresholds for leverage. If a leverage value is less than 0.2, we say is safe. The data set is safe. But if we have a value that is between 0.2 and 0.5, we can consider that value to be risky. And the leverage value that is greater than 0.5 will tell us that the observation is very risky and should be removed or avoided. How do we do that in STATA? We follow these steps. Again, you just run your regression model. And in this example, we will use the automobile data set. And then we predict the hard statistic. And then we then graph that by respondent. Here we use the ID. And then we can also list to see what are the values, the hard statistic for each ID or each respondent. And then, as usual, we will conclude whether any of these values is greater than the recommended threshold and revise our data set before we produce the final regression results. So let's do that in STATA now. So I open my STATA do file again. And here we are testing influential observation using leverage. So I will again load the data set and run my regression model quietly. Then next, I will predict the hard statistic. I'll just say predict hard, and I can also use any name. I can say hard statistic, but then I have to show that how to type the correct one, hard, before I can get it. Okay, once I produce this variable called hard, then I can graph that. I can get a box graph by each of the respondent, or in this case, MEC. Okay, let's do that now. So I'll just, let me see whether I run the regression. Yes, I did. Next, I will then predict. So I'm going to predict this and get the graph. So you see, VW diesel is the one that has the highest leverage value, and is all of them are less than 0.5. So none of them is really very risky and should be avoided. But of course, we can say that this is between 0.2 and 0.5. So these two can be considered risky, but we can allow them in our model, in our data set. And we can also sort a list just to see again, by the same thing we will see. You see that VW is having the greatest value. So these two have values between 0.2 and 0.5. All right. This is how we check for influential data using leverage. In the next video, we will then use a summary, we'll summarize all that we have discussed about regression diagnostics using one single command. All right.